Welcome back to our presentation. We would like to address question number 2, of which it is concerning what Stata 19. Um, and my colleagues will be sharing the pass, and the first one to present is
Ratio on Kimabi. Right. Firstly, let's create a working directory. So to create a working directory, we go on File and it will give us a drop-down menu. We go on the option here. That's change working directory. We click that one. Then desktop. Uh, then we rename the folder, which it will be group 8. Okay. After that, we're going to create a do file. So we just click the icon for the do file. Then we go on save and we'll name it globe 8 as well. And save. After we save a do file, then we are going to create a log file. So our log file should be in that same folder. Right, guys, let's recreate a do file. Right, we go on save on folder 2, and we again gave the name group 8. Then we save it. We save it in new folder 2. That's our working directory. Now we save it. Now, ladies and gentlemen, we have created our do file. So next, we want to create a log file. So how to create a log file? You just go to File, then you drop down menu, and click on Log. Begin. We save again as group 8. Now, now this is our our log file, working directory folder 2.
thank you for that, Lesho. Now, I was just trying to help us create our working directory and create do file and log file, of which now that takes us to our second question. Georgina will address us. Georgina, may you unmute your mic and
Okay, our first task is to to do summary statistics using dtable command. First, we have to import our data. Here we go to File, then we go in the drop down menu, then we press Import and we select Excel spreadsheet. After that, we click on Browse. Then we go on desktop where we can find our data. Then we choose students data and we open and we press OK. We then import the data. So here we write the dtable command After importing, then we write the dtable command under the command bar. Yeah, this is the summary of the data that we have. We have 160 variables. Then we go to our second task. Our second task is to create a bar graph showing the distribution of gender across family types. Here we start here because our variables are in letters, so we have to rename them in order to identify them easily. So we use the browse. So here we use the br command, which is browsing, in order to show us how the data is. And this is our data. So since you can see that the data variables are in letters, so we have to rename them in order to identify them easily. So we now we go at the command bar where we start to rename our first variable, and we write rename a id. This command will help us to change the first variable's name to first variable's name, which was a, to id. Now we also then we do the same for our required variables. Here we have renamed all the required variables. Now we are going straight to answering the question. Here we will use the command graph bar comma over, and this is our command that we are using to answer question number 2. And as you can see, this is the graph that it has shown us. My colleague will continue from question 3 going below.
Thank you, Georgina. Georgina have created the bar and also helped us to rename them, the variables. So our next colleague will continue from where she stopped. Daniel will take us to through our next question, of which we are trying to create a heat map. Okay, Daniel, it's your time.
All right. Thank you so much. So to create a heat map, first of all, it is required for us to install the required packages, which will help us to undertake this task. So the required packages are as follows, which will use a command in which it follows as ssc space install, then space heatplot. Yeah. After that has happened, we also install another package which is uh, about palettes. So we use the same command. So on here also it's showing that the packages has been successfully installed. That's when you're going to the next command, which is the same as ssc install palette. And after we have clicked OK, we also wait for it to find install. Yeah, since installing the package of Palace has completed, we also install the packages of color space, which we also use the same font. Yeah, so after installing all the required packages, this is now how time to create our heat port. So to create our heat port, which was had to have agent program, we will write the Alright, so due to network issues, we had to rerun it again, the command. So now since it has completely installed all the required packages, now it is time to create now a heat plot. So in creating a heat plot, we use the command heat plot then space h space program. We have to write that again. Yeah, so here we have successfully created our heat plot. But since we were told to explain using data nodes, now we write a command of nodes, then click OK. So since the nodes are supposed to be generated by its own, so due to the difference in Stata version, we'll just have to write the nodes. Then yeah, so since the nodes do not generate by itself, now we had to just to paste it upon it so that we may explain the outcomes of the heat plot. So the outcomes of the heat plot indicates that there is a variation in age across programs in which some of the programs have higher averages. This shows that there is a possible difference in student entry age or program structure. So it has also shown through the what? Through the colors. So that's how we have created the heat plot. Thank you.
Welcome back. We would like to continue from where we stopped. In the Aaron will take us to through our next question, of which we'd like to um, do Kineo density. So, Aaron,
Thank you very much. My name is Alan Chibangule, and I'll be proceeding from where my colleague stopped, which is here we're trying to create a kernel density plot for male and female students' age. After that, we are going to explain the results using Stata notes. So, firstly, we type in the command kdensity. Yeah, kdensity for age. As we can see, we have an error for stringed variables. Therefore, we have to destring these variables. Now we are going to punch in the command generate age num real age.
so man.
Now we destring these variables. So after destringing, we see after generating, we observe that we have two missing values. Therefore, we
Yeah, just
we now we run the command for k density for the edge num, the one we have generated. Now, as we can see, the kernel density is being shown there. Now we are going to explain this kernel density using Stata nodes. We write down the command nodes. Now the nodes are as follows. The analysis shows variation in age across programs. Some programs have higher averages, indicating possible differences in student entry age or program structure. Reaching this far, I would like to conclude and hand over to my colleague. Thank
Uh,
you.
Thank you, Aaron, for your contribution. Now, I would like to welcome Pempelo so that he will take us through the question of which we would like to upload box prod. Pempelo, you may take the lead.
Hello everyone. As my colleague has already said, my name is Bimbre Chabo, and I'm going to take you through number five, question number five, which states that create a box plot for male and female students' age. So, to create the box plot, we have to write the command graph box age age num. Yeah, so this is the command we have, right? So it's graph box age num over gender. Then press enter. Yeah, so as you can see, this is the graph for male and female. The outliers as well is also showing the outliers. Yeah. But okay, from now my colleague will take you through the other part of our questions.
Thank you, Pempelo, for your participation. Now, we would like to address the question number 5, of which it is asking us to learn the ordinary square using the wage data. As you can see, my log file here is on it, and the do file of which we're gonna put our commands is also not closed. Um, so first of all, we're gonna upload um, this file, which is called wage1 dataset. Just go on file, then open, then where we go where the file is located, and it's on desktop, wage1 data, then open. Now Stata is asking us to save the changes. What will happen here is the data after saving the after clicking the Stata is trying to recognize that I'm trying to upload a certain data and I haven't saved the changes of which I've made in this data. To preserve it or to avoid losing it, I have to save it, or I can just ignore it just because I already have this data. So I'll click on save, and I'll use the same directory which we are using as our working directory, and it's for that too. So our name is data one for group 8. Yeah, I think it's student data set. Then you hit enter. This will help you to do the same procedures which we done, like from question number 1 up to question number 4. So you can just use that data instead of coming up with the raw data. So now we have uploaded our data, and it is um, wage data 1. So the following question is asking us to learn the ordinary least square, which is just ORS. So we'll go on statistics, then linear models, linear regression, then we'll choose our dependent variable, which we can choose any, and we'll use expert. Then we'll select independent variable wage, education, expenditure, tenure, and white. You can select up to, you are not limited, but you can select 7 just for this one. Then you hit enter. Enter. I hope you are following. Now this is our result. Remember, we are using the same log file. As you can see here, it is still on. Had it been we want to use the other log file, we would close the previous one, then create another one, but we are still using the same log file for this assignment. So the following question uh, is demanding us to do the diagnostic tests and explain the results. Now we would like to do diagnostic testing. Um, may I ask the presenters? Uh, Georgina, I can see the hand. Unmute yourself and
Yes. So here we can test for multicollinearity. To test for multicollinearity, we use VIF as a command.
Georgina, you will take us. Yes, Georgina, unmute your mic and tell us how to go about with the test.
Okay. In diagnostic testing, we have different tests. Here, we test for multicollinearity. To test for multicollinearity, we use the VIF command. So,
Yes, then after that,
according to our results here, it shows that we have no multicollinearity problem since we have mean VIF, which is 0.34. This shows that we have no multicollinearity problem since multicollinearity starts from 6, 10 and above. So here it shows that Stata has no problem of multicollinearity. Thank you.
thank you very much, Georgina, for your participation. This is the results, as Georgina have said, that there is no problem of mitochondriality just because, as we can see, the digits are less than the significant digits. Now, I can see Lesho. Mute yourself and Lesho, I can see the hand. Mute
Yeah,
yourself.
right.
Yeah.
Thank you very much. As you already know, I'm sure that my name is Rest. Um, Here we want to run a command which will help us to find if there is a problem of heteroscedasticity in our data. So the command which we are going to run is state hetes.
Yes, continue.
So far, now we learn our the results. As we can see there, uh, actually the chi-square, I mean the probability is 0.00, meaning to say that in our data heteroscedasticity 4. So for the
Sorry.
minimize law,
Yes, continue. Sorry.
hello,
Yes, continue.
yeah, for us to minimize that problem, we can learn the command which is robust.
Thank you for your participation. Thank you. As you can see,
Okay.
thank you, Lesho, for your contribution. Yes, the heteroscedasticity test is showing that the probability is significant, which means we have the problem of um, we have this problem. So we have to reduce it, as I've already said. We use robust. How do we run robust? But before we do that, is there any test that we can do? Anyone? Or okay, I hope I can see no hands. So we correct the problem. Now we just regress, then comma, then robust at the end, then hit enter. Now, as we can see, what robust does is it tries to minimize the errors. So, as you can see, um, r squared is 0.9, of which the uh, overall significance is, and the adjusted r square is also above 90, showing that our independent variable is being explained by these independent variables, and the overall statistic is significant. So now, next we have to uh, learn logistic regression to predict birth weight based on age of mother, race, and smoking during pregnancy using the LBW dataset. What we have to do here is we are going to use another data. As we can see, there is no race, mother, and uh, I would like to ask Pempelo to remind us of this command to use the data which is automatically stored in Stata, or it is downloaded on Stata using the command web use web use LBW here, and we hit enter. Now, as we can see that our data of which we uploaded earlier has changed. Now we are using another data, and you may be surprised that it didn't ask us to change whatever. This is just because this is data which is already online. So we do the requirement of which it is telling us to run the logistic regression. Now the command is log sorry log log, then we select low, then age, then smoke. Sorry, I forgot one variable, which is race, then smoke. Then we have to run our logistic, and these are results. As you can see, we don't have error statistic or adjusted error. We are having a pseudo error square, which is just so that's it. We are having pseudo error square just because we are having dummy variables, maybe we can say, but we don't rely on this pseudo error square to explain the overall significant as the previous question. So the next thing is we have to calculate the marginal effect. So the command is just margin, then you hit enter. So that's the predicted margins. Number of observation one, it is 9. Probability low, predict, yeah, that's the our margin. And our constant is margin is 31%, I can say, and Z is 9.6, yeah, and it is significant. The overall, as we can see, the probability is 0.000, so it is significant in that case. Now we're gonna use this the final question is suggesting us to is telling us to sorry is telling us to run a probit model to predict foreign based on weight and MVG using the auto dataset. Seus auto. Okay, the command is Seus auto at the end. There's this, as you can see, auto. This data is stored automatically in Stata. Just you can access it, not on web, or you don't have to upload it. It is just already there. So you run, then as you can see, here the variables have also changed. Now we have to use the MP. We have to run the probit model using the variables mpg, foreign, weight, and mpg. So what you just have to do is probit foreign. Oh, sorry, I can just select them over here. Okay, we just select foreign, then weight, then mpg, then we run our model. So this is our probability regression model, whereby we also have pseudo error. In the Z's scores are negative 4.1 and negative 2 point, and the constant is 8.2. Reaching this far, this marks the end of our presentation, not presentation actually, but the end of our question 2, which was asking us to use Stata to do this task. And as you have noticed that I haven't used my do file, but what do file does is you just have to select these commands: Control A, then Control C, then you paste them here. Then you can do the, as you can see, all the commands we have run are stored here. And uh, what do file does is it just helps you to rerun every each and every command which we have just entered, and it will give you the same what, the same uh, the same results as we've seen, the hit plots whatsoever, and yeah, extra. In the our log file, we haven't closed it, but reaching this far now, we can close it, so that you can see here it is on, so we can close it so that we can do other work as we praise. So I'll just hit close. Then it has just notified us that this do file has been closed on, uh, do file has been closed on for me. So yeah. Um, that's it. Thank you for watching. Sorry, I haven't saved my file. Thank you for watching. My name. Uh, you may be wondering, but my name is Luz Chivembele. I was the yeah. I was the one organizing the meeting. So thank you for taking part.
Thank you, Zoe. Thank you.